Okay, today we're doing 6-2, which is a difference of squares, factor pattern, page 268, 1 through 76 odd. So we'll start with a little warm-up, pause the recording, and try these problems. Now let's check our work. Okay, so if you notice when you FOILed or double distributed, you notice that when we multiplied x plus 3 times the quantity of x minus 3, we ended up with x squared minus 9x, minus 9. And that's because when we take x plus 3 times x minus 3, when we multiply it, we get x squared, the first terms. The last terms, we're going to get minus 9. The outside, oops, sorry, didn't mean to do that. The outside terms would multiply to minus 3x. The inside terms would be plus 3x. And you'll notice those inner and outer terms disappear so that we're only left with x squared minus 9. Okay, so if we follow the pattern, you should have gotten m squared minus 49, y squared minus 100, and t squared minus 64. Our inner and outer terms are canceled when we get a difference of squares. So now what we're going to do is we're going to start with the product. So the first one, it's real easy. I don't want you to add an equal sign. When you have x squared minus 9, I expect you to write it and then start your answer right down here, the factoring down here. So it's pretty easy. We take x squared, and the root of x squared is what, Cameron? X, so I place it in the first position of the binomial. And then the root of 9 is what, Cameron? 3. And then if it's a difference of squares, a perfect square minus a perfect square, the pattern is one's a plus and one's a minus, and the order doesn't matter. Now in my PowerPoint, you're going to see an equal sign, but I don't want to see you guys do that. Okay? Your answer should be right underneath. Okay, let's try another. The next one breaks down to m plus 7, m minus 7. Pause the recording and try the next ones on your own. All right, let's check our work. Okay, let's go for, I want to hear from people I haven't heard from. How about Dayana? And? Not y plus 10. What's the pattern? Y minus 10. Plus and minus. Next one, let me hear from Kate.
I got t plus 8 and t minus 8.
Okay, next one, Bryce.
I got x minus y times x plus y.
Times the quantity of x plus y. Good. Next one, Rami, in order.
I got 4 plus k times the quantity of 4 minus k.
4 plus k times the quantity of 4 minus k. And our last one, let's go, Veronica.
I got p plus 1 times the quantity of p minus 1.
Perfect. All right, so you might want to draw a line right there, and we're going to write a list of things. And I want you to write today, yesterday we started greatest monomial factor. That's your GCF. Today we're studying difference of squares. I would like you to make this list so that you have enough room to finish it, but leave space, but we're not going to finish it today. You're only going up to number 2. So pause the recording. On the left side of your Cornell notes, we can call this 5 types of factoring. Okay, you're going to have more room. I would write factoring and then start naming it. Okay? So pause the recording, leave enough room that on another day we can come back to 3, 4, and 5. Pause the recording and take your notes. Let's continue. So, a difference of squares. Draw a line. Make sure there's extra room that you can go back to that. On your left side, you're going to write that term, difference of squares. So, on the left side, you're going to write difference of squares. And on the right side, you're going to write this, x squared minus 25 equals x plus 5 times x minus 5. And this is what we call a perfect square minus a perfect square. That's the pattern. When you see a perfect square minus a perfect square, your binomials will be the same, but the signs in the middle will be different. Okay, I'm going to actually erase this so you know to write difference of squares on the left, and you can copy these here. Okay, and when you're done with that, you're going to draw a line, and on the left you can write perfect squares. Perfect squares. Pause the recording. Perfect. So for your Cornell notes, there's going to be a line, and over on this side, it's going to say perfect squares. Okay. Okay, and so now we're going to list them. Okay? You don't need to write the directions. We're abbreviating our directions right here. So let's go with, does anybody know what the first perfect square is? Go.
2.
Nope.
4.
Yes.
1.
1 is the first perfect square. The next perfect square, Carter? 4. The next perfect square, Bryce?
9.
9. The next one is, go, Annabella? 16. Okay, how are we getting these? Eitan?
Each of the numbers you listed can be have the root.
Okay, how am I getting and knowing this order? Yes.
You're starting with 1 and you're squaring it, and then you're
1 squared, 2 squared, 3 squared, 4 squared. Okay, what would be the next one be, Dakota?
25.
Yep. Shivam?
36.
Good. The next one, Max?
I don't know how to write this down. 49.
49. Elizabeth?
6. Oh, okay, now again.
All right. What would be next, Max?
It would be 8 times 8 is 56. God.
No.
No, what is wrong?
Times table.
Okay. Okay, can we try it one more time, Max?
Let's do it again.
9 squared?
9 squared would be 81.
81. 10 squared, go, Rami. 100. Next one, Matthew.
It's 200.
Shh, we're not going to 200, we're going beyond. Go.
22.
Nope. Oh my God, you guys are. Go.
121.
121. Next one. Shh, Ashley. You should have those all memorized. The new ones that you're going to learn, that I'm going to ask you to go to 25. Go, Roman.
169.
Yep. Next one, go. Only raise your hand if you know it. Ayla? 196. It's the reverse, right? The next one. Okay, so that's 13 squared, 14 squared. Okay, you need to know these or your time will be sucked up while you are taking tests or doing homework. So this is 13 squared. This is 14 squared. 15 squared is 225. 16 squared is 256. 17 squared, you're writing this down as I write, 289. 18 squared is 324. 19 squared is 361. 20 squared is 400. That's an easy one. 21 squared is 441. 22 squared is 484. 23 squared. Okay, 23 squared is 529. 24 squared is 576. And 25 squared is 625. Okay? What comes up all the time is through 20 squared and 25 squared. But I have seen 21, 22, 23, 24. If you take the time to memorize them tonight, I promise you for the next 4 years, you will not suck up your time because there is nothing worse than trying to factor 576. But if you have it memorized and know that that's 24, you could sit there for a long time trying numbers that multiply together to 576. So do yourselves a favor, get these memorized. Is this a question we're going to record?
I don't know.
Got to keep going, okay? So I erased the rest of those. So now let's take a moment, and I want to see you guys try these next ones. I'm going to give you one sample. It's x plus 9 times x minus 9, right? Make sure you are numbering and ordering them. Pause the record. Let's check our work. Number 2, how about Alana?
I got 3m plus 11, and then
Times the quantity.
times the quantity of 3m minus 11.
Perfect. Okay, next one. Let's go Madison.
I got 4 plus 7k times the quantity of 4 minus 7.
Okay. Next one. Let me go with Max.
K squared plus 2 times the quantity of k squared minus 2.
Can k squared minus 2 be broken down some more?
Yeah.
What? Yes?
It could be K. Like,
Okay.
K plus. Well, K times K.
No. I said, can k squared minus 2 be factored again? There's no GCF. Okay. K squared minus 2 is a difference of squares. It can be factored. Wrong. Why? First one's a perfect square. Is 2 a perfect square? No, it cannot be factored anymore because 2 is not a perfect square. Next one, David. Number 5. Carter.
I think it might be t times t minus 50. I wasn't sure after this because 50 is not good.
David? Anybody?
Conscience.
Mark?
T minus 7.5 times
No.
T plus,
Go. Oh, what were you going to say? 7.5? What?
T minus 7.5 times T plus 7.5.
No.
I forgot how to
Yeah.
Okay, that's not going to work.
Why is there a capital?
7.5 times 7.5 does not equal.
Yeah, no.
Okay.
No, it's
Shh. 7.5 times is no. Okay. I need a whole number. Do you have a whole number?
Yes.
Okay.
T minus 5 times, because then.
T minus 0 minus 10.
Oh no, but then they're gonna have to times them up again.
Go, Annabella.
T minus 10 times t plus 5.
Okay, T plus 5. That's what they came up earlier. Thank you for blocking that. So we get T squared first. Outside is plus 5T. Shh. Then I have minus 10T. And then I have minus 50. So that makes T squared minus 5T minus 50. That didn't work. Alex.
I think you just leave it alone because 50 isn't a perfect square.
Right. It's the single most overused word for an algebra student second semester is not factorable. So please don't overuse this. The likelihood that I will give you something that's not factorable, not often. And I have some students on their tests, they write, every time it gets hard, they write not factorable. Okay? Oh my God, I can't factor it. Not factorable.
like big numbers.
Shh. Yeah. Okay. Shh. Shh. So 50 is not a perfect square. That's why it's not factorable. It's a difference of squares. Number 6. Veronica. Shh.
2x plus 7 times the quantity of 2x minus 7.
Good. Next one. Julio.
6y plus 1 times 6y minus 1.
Next one. Rami.
I got 4x plus 5 times the quantity of 4x minus 5.
Agree?
No.
Why? Because I said agree. Right? Okay, let's try it. That becomes 16x squared minus 25. Shh. So you want to make that a plus?
Yeah.
Shh. So he's saying, quiet.
No, it doesn't work.
Okay, so we're going to try that. That becomes plus 20x plus 20x plus 25. Is that going to work? That becomes 16x squared plus 40x plus 25. Yes.
Negative 4x plus 5.
Oh, I got it.
No.
It's 4x plus, no, it's minus 5 times 4x minus 5.
That would be minus 40x in the middle. Shh. Ayla.
A perfect square has to have a, it has to be subtracted.
So what are you saying to me?
Not factorable.
Right, it's not factorable. I never said to you that a sum of squares was factorable. In fact, let's go over to our chart, which you're not here, but let's take a look. I'm going to bring the iPad so you can, our people that are being. In the real life, we're going to get a problem. The first thing you're going to do is look for a GCF. If it doesn't have a GCF, you move on. If it does have a GCF, you factor it out, and then you move on. Okay? If you're left with a binomial, two terms, the only kind of binomial we can factor is a difference of squares. Right here, here's an example. Here's how it looks. A sum of squares, I have it written here, but notice it says not factorable. So anytime you have a plus sign in the middle of two squares, there's no two quantities that you can multiply that will result in a sum with that plus sign in the middle, two perfect squares with a plus sign. Okay? So this is not factorable. Is everybody clear on that?
Yes.
The t squared minus 50 is not factorable because 50 is not a perfect square, and this is not a difference of squares. Everybody say difference of squares. All right, so now we're going to look at what we're going to see in the real world. Well, when we really start using this, because, okay, you're drawing a line, you're saying factor completely. So step one, we get a problem. We're going to follow the chart. The first thing, what do? What do? We look for a GCF. Does this have a GCF? 2. So I factor out my 2, and what's left? X squared minus 25. Is it completely factored?
No.
So I don't get to stop.
No.
What can still be factored, Cameron?
5. No. Yeah, 5. 20.
Okay, go, Roman.
X squared minus 25.
Good. So I bring down my 2, and then I'm going to factor the x squared minus 25 to what? Keep going, Roman.
X plus 25 times...
No, x plus what?
Oh, sorry, 5.
X plus 5 times
X minus 5.
x minus 5. Am I completely factored?
Yes.
Okay, this is the answer you're putting in my answer column. Okay, the next one. You should be writing while I'm writing. Okay, Elizabeth. Okay, how am I going to factor that? Is this a difference of squares? Is this a perfect square? Is this a perfect square? Yes, 1 is a perfect square. That was on our list. And is this a minus sign? Yes. So we're following that same pattern. So what do you think it is? What's the root of what times itself equals m to the 4th? M to the 2nd. M to the 2nd. What goes in the other place? Minus 1 and positive 1. Are we done? Is it completely factored? Why, Roman?
Because they're both, they can both be factored.
Can they both be factored?
They're
No.
both, perfect square.
Okay, what's perfect squares? Pause the recording. Hold on. Going. What are we doing? What can be factored? Somebody. Annabella.
You get both the m squared and the 1 all perfect squared.
Okay, so only this can be factored. The other m squared plus 1 can't. So this is a difference of squares here. So that factors to what, Annabella?
M minus 1
Times.
m plus 1.
Shh. And then I bring this one down, It's m squared plus 1. I generally put my difference of squares on the right side so I can build it out. Okay? Yes.
Why can't you factor the m squared plus 1?
Because it's a sum of squares, not a difference of squares. All right, let's try 2 more. Let's try 2 more. Okay? You can pause it if you want to write. Okay, step 1, what am I doing? Shh. Let's go, Diana. First step, look at the chart if you forgot. Okay, so what is the GCF? What divides into both? Okay, so I take a 3. What's left? Minus what? You divide it by 3. What? 9. Good. Are we done?
No.
Keep going, Diana. How do I factor y squared minus 9?
3 times y minus 3,
Times the quantity of?
y plus 3.
Perfect. Do you see how that is factored completely?
Yes.
Okay, let's try the next one. I love this one. Okay, who wants to give it a go? Write it down as we're going. We're out of time. So, who wants to walk me through it? We're going to do this. Okay, don't pack up. Ashley. Shh. Number 2.
Okay, so that would be x squared minus 9
Times quantity of?
times the quantity of x squared plus 9.
Plus 9 times x squared minus 9. Are we done? No, the first one, we're going to keep it. X squared plus 9. And then the second one factors to what, Ashley?
Times x.
No, we don't write x times x.
Oh, so it would be x plus 3
Times.
times x minus 9.
Okay, stop. Let's look at this number 3 and 4. Sorry. Please do not pack up. It will take 1 minute. Notice I factor out my GCF. Now, when I break down m squared, m cubed, m to the 6, it becomes m cubed. Let's say it was m cubed minus 4. Could you factor that?
No.
No, because m cubed is not a perfect square. No number times itself. Next one. These kind, you're going to have to watch out. Because remember, I'm going to be able to, this is called a fourth degree polynomial. So you'll notice I have another difference of squares left within the difference of squares.
Yeah, and
Okay, and that's the lesson.